In our previous video, we learned entropy and change in entropy, and we showed whether it is positive or negative. Here we'll find some value of the change in entropy, which usually comes in past papers. You'll see that it will come in A-level questions. I will show you a very simple example. Here, hydrogen is reacting with half oxygen to make 1 mole of water. And the value of the entropy is given. The entropy of hydrogen is 20 joule per Kelvin per mole. And oxygen is 30 joule per Kelvin per mole. And the entropy of water is 60 joule per Kelvin per mole. It is not kilojoule, it's joule per Kelvin per mole. Please remember that. Now, what is the delta S? It's very simple. Delta S is equal to the entropy of product minus entropy of reactant. So the product is H2O. How many moles? 1 mole. 1 mole, 60, right? So 60 minus the entropy of reactants. What are the reactants? Here, this is one reactant, this is one reactant. This is 1 mole, and 1 mole has an entropy we know from this here, it's 20 joule per Kelvin per mole, so 20. But here, oxygen is half mole. We know the entropy of oxygen is per mole is 30. So it would be half into 30, right? Because there is half mole. So you calculate, it's 20 plus 15, 35, and you get 25 joule per Kelvin per mole. It's easy, isn't it? It's really easy. Now, when we are calculating delta S, we need to remember that, keep in mind that number of mole, because the values are given per mole. So if it is another equation, for example, say H2 plus O2 and then liquid. This is the same reaction with different moles, right? You're producing 2 mole of water. How do you calculate delta S? You'll see as a product. Here the product is 2 into 60, isn't it? Then the reactants would be 2 mole of hydrogen. Hydrogen is 20 kilojoule per mole, so it will be 2 into 20. And there is 1 mole of oxygen, so I will just write 30. I will just write 30. And what will be the value of the entropy? Let's see. 60 into 20, 120 minus 40 plus 4, 70. So it will be 50 joule per Kelvin per mole. I think it's easy to, I hope that you'll be able to calculate the delta S, the value of delta S from different equations and different moles if given. And do not forget that the value of delta H, when we calculate this enthalpy of reactant minus enthalpy of product. But here it is the opposite. It's enthalpy of product minus enthalpy of reactant. Remember that? Delta H, we find the bond energy of the reactants first, then we subtract it. We subtract. When we calculate bond enthalpy, delta H of a reaction, what we do? Bond energy of reactant minus bond energy of product. But here it is not like that. Remember, it is product minus reactant, not reactant minus product. This is something that you need to keep in mind. I hope you understood.